Hello friends, welcome back. Today we will see function of square matrices, a new part in matrices, in which we are going to see a calculation of the powers of a matrix. As usual, we have calculated a square by simply multiplying a with a cube by a square into a, and the all powers of a like this. Here we are going to see if A is non-singular square matrix, that means the determinant of A is not 0 with distinct eigenvalues, then we can find any power of A. So as we know, M inverse A into M is equal to D, because A is similar to diagonal matrix D. Pre-multiplying by M and post-multiplying by M inverse on both sides, we will get M into M inverse AM into M inverse is equal to M D M inverse. Now combining M and M inverse, we will have M into M inverse A into M inverse. In the RHS, M D M inverse as it is. So we know that A into A inverse is nothing but identity, hence M into M inverse is also identity, and the rest thing is A into identity is equal to M D M inverse is equal to, so equation 1 states that A is equal to M D M inverse. Similarly, we can calculate A square by simply multiplying M D M inverse with itself. So M D M inverse equal into M D M inverse. Now combining M inverse and M, we will have MD in bracket M inverse M into D M inverse is equal to MD. M inverse M is nothing but identity, because product of matrix and its inverse is equal to identity, as we have seen in the 11th standard. Therefore MD identity into D M inverse. Therefore M into D square, because D into I is D and D into D is D square, hence it is DM MD square M inverse. So in this way we can calculate any power of A, that is A to the power n equal to M D raised to n into M inverse. Okay. Similarly, we can calculate any function of A, or any power, or any exponential, or any trigonometric, whatever the question is. Problem number 1, we will see if A is equal to 2112, then find A to the power 50. You can write this question as if A is equal to 2112, then find A to the power 100, also 101, 200, etc. You can try at your home independently. To solve this type of question, we need to solve a characteristic equation of given matrix, and the characteristic equation of a matrix is nothing but the determinant A minus lambda I equal to 0. And we well known that characteristic equation is written as lambda square minus sum of the diagonal element into lambda, which is 4. Therefore lambda square minus 4 lambda plus determinant, that is 3, is equal to 0. So as we have seen this from 7th to 8th standard, and this one is a routine work for us, therefore we have written here lambda is equal to 1 3, because roots of quadratic equation given above are 1 3. So eigenvalues are distinct. Clearly 1 is not equal to 3, hence it is distinct. So eigenvalues are distinct, and the matrix is non-singular, because product of determinant of matrix is nothing but product of eigenvalue, and determinant of matrix is equal to product of 1 and 3 is equal to 3, and is not equal to 0. Therefore given matrix is non-singular. So we can calculate any power of A by using A raised to n equal to M D raised to n into M inverse. Okay. So M is model matrix that we have seen in the last lecture. M is obtained from eigenvectors of A corresponding to the eigenvalues. So M is model matrix or transforming matrix or diagonalizing matrix. So in the next we will see for lambda is equal to 1, a minus lambda I into capital X is equal to 0 gives 1 1 1 1 into x1 x2 is equal to 0 0. R2 is changed by R2 minus R1, so that we can write R2 as 0 and R1 remains as it is. So matrix 1 1 0 0 into column vector x1 x2 is equal to 0 0. Now here we have seen that rank of coefficient matrix is 1. Rank is 1. Unknowns are 2, x1 x2, is it? So how many linearly independent parameters are to be used here to solve system of linear equation? So 2 minus 1, that is 1. One linearly independent parameter that we have to use. So therefore system is written here as it is. Okay, and we have to use one linearly independent parameter. Name it as x2 is equal to minus t. तुम्ही काही घेऊ शकता, काय problem नाही. As x2 is equal to minus t, then x1 is equal to t. Therefore the vector is t minus t and it is 1 minus 1. Now for second, lambda is equal to 3. A minus lambda I into x is equal to 0 gives 2 minus 3, which is minus 1, 1 as it is, 1 as it is, and here it is minus 1, x1 x2 is equal to 0. So in this we will perform the operation. R2 is changed by R2 plus R1, so that we can write R1 as it is and R2 is 0 here. So this one is a column vector as it is, 0 vector as it is. So system of linear equation in matrix form is written in algebraic form as minus x1 plus x2 is equal to 0. Here we have written here. Now see, the rank of coefficient matrix is 1, unknowns are 2, hence we have to use only one linearly independent parameter. So put x2 is equal to t in this equation. We get vector is 1 1. So model matrix is performed or obtained from the characteristic vectors as m equal to first eigenvector, that is written here, first eigenvector 1 minus 1. So in the first row we will have first eigenvector 1 minus 1. In the second row, the second eigenvector that we have seen here. Okay, and we also know that if A is equal to A, B, C, D, the determinant of A matrix A is nothing but AD minus BC, and M inverse is given by adjoint of A divided by determinant of A, and it is we have calculated that things. Okay, so M inverse is equal to determinant of M inverse is nothing but 1 upon determinant of M, which is equal to 1 plus 1, which is 2. Therefore 1 upon 2 into adjoint of A. Adjoint of A is given by simply replacing the diagonal elements and changing the signs of non-diagonal elements. So we have seen that 1 and 1 are the diagonal element that we have interchanged in this way, and non-diagonal elements are 1 and minus 1. So we are going to change only signs of non-diagonal element, and that we have written here. Okay, here positive, here it is negative, here it is negative, here it is positive, and this one is replaced from this one. Okay, so like this. Now D is nothing but the diagonal element obtained from eigenvalues of A, and D is equal to 1 0 0 3, because 1 and 3 are the eigenvalues, hence we can place eigenvalues on the diagonal entries. So D raised to 50 is nothing but 1 raised to 50 0 0 3 raised to 50, because we know that if A is diagonal matrix, then A to the power n or any natural number is equal to diagonal च्या एंट्रीज आहेत ना त्यांची पॉवर असते, त्याच्यामुळे ते असं लिहिता येतं आपल्याला. Therefore A raised to 50 is equal to m d raised to 50 m inverse. हे कशावरून लिहिलं इथं बघू शकता तुम्ही. A raised to n equal to m d raised to n m inverse या लाईनवरून. कोणत्या? So from this line we have written here A to the power 50 equal to m d to the power 50 m inverse. So value of m is nothing but 1 minus 1 1 1. So here it is m that we have replaced here. D raised to 50 is nothing but 1 raised to 50 is 1. Any natural power of 1 is 1. 0 as it is. Here it is 0 as it is, and 3 power 50. We are not going to calculate the value of 3 power 50. If you have a calci with you, then you can write it. Otherwise leave as it is. And m inverse is 1 by 2 1 1 minus 1 1. So this is from this one. Okay. So in the next line we are going to calculate the product of these two matrices from the RHS. Okay. So 1 upon 2, here it is 1 upon 2 is a constant. We can take it common and multiply this matrix with this one, and product of these two matrices furtherly multiplied by with this matrix. Okay, so let me show you in the next page. So A raised to 50 is equal to 1 upon 2 1 1 minus 1 1, that is m as it is. तो LHS सॉरी राईट हँड साइड मध्ये लेफ्टला होता तो तसा लिहिलेला. त्यानंतर 1 minus 1 3 power 50 3 power 50 is the multiplication of these two matrices. Now multiplying these two matrices we will have 1 3 power 50 is nothing but 1 plus 3 power 50, and then minus 1 plus 3 power 50. Here it is minus 1 plus 3 power 50, and last one is 1 plus 3 power 50. So this is the required answer. Here we have written A to the power 50. A to the power 50 is equal to 1 upon 2 1 plus 3 raised to 50 1 minus 1 plus 3 power 50 minus 1 plus 3 power 50 1 plus 3 power 50. So this is the required answer. It is asked in May 19, November 18 Mumbai University examination. So problem number 2 is that if A is equal to 3 by 2 1 by 2 1 by 2 3 by 2, then find e to the power a and 4 to the power a. The characteristic equation of A is nothing but determinant of A minus lambda is equal to 0, and this is written in this way: lambda square minus sum of the diagonal element, which is 3 by 2 plus 3 by 2 is 3. Okay, so lambda square minus 3 lambda plus determinant of A, that is 9 by 4 minus 1 by 4, which is equal to 8 by 4, and that is 2 is equal to 0. As we have seen the quadratic equation, lambda square minus 3 lambda plus 2 is equal to 0. So 1 and 2 are the roots of this equation. So eigenvalues are distinct here. 1 is not equal to 2, hence eigenvalues are distinct. Therefore for lambda is equal to 1, matrix equation A minus lambda I into capital X is equal to 0 gives 1 by 2 1 by 2 1 by 2 1 by 2 into column vector is equal to 0 vector. Now R2 is changed by R2 minus R1, so that we can write system of linear equation as 1 by 2 x1 plus 1 by 2 x2 is equal to 0. Okay, so row R2 is 0. Now put, because rank is 1, number of unknowns are 2, and 2 minus 1 is 1, so we use 1 parameter. Put x2 is equal to minus t, therefore x1 is equal to t. Hence vector is 1 minus 1. Now for second eigenvalue, a minus lambda I capital X is equal to 0 gives minus 1 by 2, 1 by 2, 1 by 2 and minus 1 by 2 into column vector and the 0 vector. So to perform or to transform this matrix into echelon form, we will use to perform the operation, row operation as R2 plus R1. So that we can write minus 1 by 2, 1 by 2, 0, 0, second row will be 0 here. Now minus 1 by 2 x1 plus x by 2 x2 is equal to 0. So as usual in the many of the example we have seen the rank and number of unknowns and linearly independent parameters. So we are not going to write here the things. Put x2 is equal to t, we may have x1 is equal to t, hence the required eigenvector is 1 1. Now m is obtained from the eigenvector. First eigenvector is 1 minus 1, so that we can write here 1 minus 1 and then the 1 1. Therefore m inverse is as usual 1 by 2, 1 1 minus 1 1. So d is equal to 1 2, which is diagonal matrix obtained from the eigenvalues of a. Now if f of a is equal to e raised to a, polynomial in a is nothing but e raised to a, then f of d is equal to e raised to d, because if you have this thing in your hand then you can write this one as it is. Okay, so replace a by d only and write it as. And also if f of a is equal to 4 to the power a, then f of d is equal to 4 to the power d. Okay, now see here, e raised to d is nothing but e to the power 1 first eigenvalue, 0 0, e to the power 2 is nothing but second eigenvalue. Okay, so this is from this. 4 to the power d is nothing but 4 to the power 1, 0 0, 4 to the power 2. So e raised to a is equal to m e raised to d m inverse. Okay, so using that fact, 1 minus 1 1 1 into e 0 0 e square into 1 by 2 1 minus 1 1 1. Okay, so 1 by 2 constant, and we are not going to deal with that. 1 1 minus 1 1, first matrix is written as usual. Second, the product of these two matrix is written just below it, that is e minus e square e square. Now product of second and third with 1 is e plus e square minus e plus e square minus e plus e square e plus e square. So this is the required answer, a to the power a. Are getting my point? I hope you all are getting this. Now 4 to the power a is equal to m d m 4 to the power d m inverse as usual. So this is equal to m as it is. So 4 to the power d, okay, 4 to the power d is nothing but 4 0 0, 4 square is 16, and that we have written here, and the m inverse is. Now 1 by 2 constant, I am taking it outside. So 1 minus 1 1 1, here it is 1 minus 1 and second column is 1 1. Now product of second and third matrix is 4 minus 4 16 16, that will be 1 by 2 20 12 12 16, and that will be 10 6 6 10. So this is the required answer. So in this way we are going to see how to calculate the powers of a and functions of a. So in this article we are going to see some more example like this and understand the importance of this concept. Okay, thank you.